Hello everyone. In this video, we're going to learn how to find the domain and range of the function given order pairs, mapping, tables, and continuous or discontinuous functions. Alright, first, we need to understand what is the domain, what is the range. So, domain, normally we think about the input. So if you have the machine right here, all right, and you want to make coffee, right? So this is output, this is input. So input right here, you need to put something right here, right? So you need to put water, right? You need to put coffee, seed, right? In order to get the coffee liquid, right? So coffee liquid get out right here. So I have a cup of coffee right here, right? This is output. So normally in math, we're going to talk about the input, which means we talk about S value. So S value represents inputs. Y value represents output. All right, so domain is a list of all possible values of S that make the function defined. Now, we're going to talk about the range. Is a list of all y values that correspond to the S value. Alright, so domain, which means S values, range, which means Y values, right? Now we look at the first example right here. So domain, we just put the curly brackets right here. Alright, we list all S value, but if S repeating, you just write one S value, right? So domain is going to be -5, 9, -1, -9, right? And that's it. Domain right here. And in range, we just list the Y values. So, which means this guy, this guy, this guy, this guy, and then this guy. So it's going to be 7, 3, 5, -6, and 8. Done. Now, if you given the table, how do you find domain and range? Now you do the same thing as the order pairs. So domain, you're gonna list all S value. So domain is gonna be right here. So I have -7, -4, -2, 8, 10, and 19. Now range, I need to list all Y values. So it's gonna be right here. So this is my 12, 9, -11, 17, 6, and -5. Now, if I given a mapping diagram, how do I find the domain and range? Now, I do exactly the same thing. So domain, I need to list all possible S value, which is the one on the left right here. Right, so domain is going to be 0, 1, 3, and 8. Now range, I need to list all possible y values, which is the one on the right right here. So it could be 2, 3, 5, and 8. Let's move on to the next one. We need to find the domain and range of the continuous function. Now, in order to find the domain, we need to find the left endpoint. The left endpoint of the graph, it should be right here. Alright, so right here, we start from here. We draw a horizontal line. So, this is where I start, because the graph starts from here. To the right, I see the arrow right here, which means I put the arrow right here. Now, to the right of the x-axis, this is positive infinitive. To the left of the x-axis, this is negative infinitive. To the top of the y-axis, it could be positive infinitive. And to the bottom of the y-axis, it could be negative infinity. Alright. So, the domain I start right at -2, so I put -2 right here. Now to the right, because I see the arrow, which means the graph keeps going forever, so which means this is going to be positive infinity. So I need to put s in the middle. Alright, right at -2, I put -2 right here, less than or equal to. I need to include -2 because the graph has the closed circle right here. Alright, I put less than infinity. This is not a common way to write. So in order to write this one another way, we need to write as greater than or equal to -2. This is my answer. Okay, now range, which means we're gonna go from bottom to top. The bottom of the graph starts right here. Alright, so I draw a vertical line right here, and I start from the bottom right here. And I look at this one right here, I see that the arrow point up, which means this guy goes to infinity. And the bottom right here should be -4, right at -4. So I have -4 right here, and this is infinity. So the range, which means the y value. So y value greater than or equal to -4. Because -4 right here is staying on the graph, right? So less than positive infinity. I have another way to write this one. I just write y greater than or equal to -4. Alright, let's move on to the next one. For this function right here, the domain I just write s right here, range I write y value. Alright, now domain I start from left to right, so left endpoint is going to be -2 right here. Alright, so I draw a horizontal line like this. So this one right here, I include -2, so I have -2 right here, less than or equal to, right, because I have the closed circle. Now I look at the right hand side right here, I see the arrow, so which means this guy is going forever, which means it's going to be positive infinity. So I have this guy less than positive infinity. Alright, so keep in mind, right at positive or negative infinity, please don't put the equal sign. Alright, another way to write this one, I just write as greater than or equal to -2. This is my answer. Alright, for the range, I'm gonna go from bottom to top. The bottom of the graph starts right here, right? This is the bottom of the graph. So I start right here, all the way up. And you see that the graph keep going forever, going up like this. Alright, so I put the infinity right here, positive infinity. And this guy must be -1. I need to include -1 because I see the closed circle right here. Right? So I put -1 right here. This is my left. And this is right here. Should be positive infinity. -1, I need to include, so I put the equal sign. This side less than. Alright, another way we need to write it. It's going to be y greater than or equal to -1. This is the answer. Alright, now look at example number 3 right here. Domain, we're gonna go from left to right? So we have S right here. Range, we're gonna go from bottom to top, right? So we put Y right here. Now, my left endpoint right here, because I see that the graph keeps going forever to the left, right? So the left should be -infinity, right? I draw the horizontal line. Now, the right endpoint's right here, so I stop right here. This is the open circle, right? So I stop at 4, right? This is -infinity. So I start from -infinity less than s less than 4. I don't put equal sign right here because I see that this one has open circle right at 4, which means 4 is not included, right? So I rewrite this one as less than 4. That's it. So this is my answer. Now, this one right here, y, the bottom right here. So the lowest point should be 16 right here. So we start from 16 all the way up. And you see that the graph keeps going up forever, which means this is positive infinity. And the lowest point right here should be 16 right here. And I don't include 16 because I see this guy has the open circle. So this guy should be open circle right here. So I put 16 right here less than y. There is no equal sign. Less than infinity, positive infinity. So my final answer should be y greater than 16. Alright, let's move on to example number 4 right here. Alright, so I need to draw a horizontal line to find the domain. Alright, so I'm going to start from the left endpoint. The left endpoint right here, I see that the arrow point to the left, right? Keep going forever to the left. So the left endpoint must be -infinity, right? Draw the horizontal line, right? The arrow point to the right, which means it's going forever to the right. So the right should be positive infinity. So the answer must be -infinity less than s less than positive infinity. This is not a common way to write it, right? Normally, if you see the left and the right endpoint, they are both positive or negative infinity, you need to write all real numbers. Alright, now the range, we start from bottom to top, and the bottom, we see that the arrow keep going down, right? It's keep going down, so it's going to be -infinity right here, and draw a vertical line, and you see that the arrow keeps going up forever, right? So this is positive infinity. So the range is same thing, -infinity less than y less than positive infinity. This is the same thing as domain, so it can be all real numbers. Alright, let's take a look at example number 5. Alright, in order to find the domain, we go in from left to right, right? So we'll put S right here. Right, left hand side, left end point, the arrow point to the left and keep going forever to the left, so which is -infinity right here. And then from left to right, the right end point stop at number 3 right here. Alright, but number 3 right here, we have the open circle right here, so we don't include 3. So we just have the less than 3, and this is greater than this, right? I want to rewrite this one as less than 3, like this. For the range, we're gonna go from bottom to the top right here. So bottom right here, which means negative infinity because the graph keeps going down forever. So bottom should be negative infinity less than y. Now the top right here, this is the highest point, right? So right point right here, the highest point right here should be 16 right here. So 16. So I put 16 right here, and then there is no closed circle right here. So I need to put the less than. I don't put it equal sign right here. Alright, so I need to rewrite this one as y less than 16. Alright, number 6, number 7, number 8, same thing, right? Now let's move on to number 9 right here. We need to find the domain, right? The domain, we need to go from left to right. You see that? Go from left to right, we only have one line right here. And then we only have s equals 6 right here, right? S remains unchanged, right? So the domain s equal to 6. That's it. There's nothing else. The range, we're gonna go from bottom to top, and you see that bottom right here. It's gonna be going down forever, which means this is negative infinity. The top right here should be 15, right? We put 15 right here. But right here we have the open circle, so we put the open circle right here. So we don't include 15. So we have negative infinity less than y less than 15. In other words, we just write y greater than 15. That's the answer. Now let's move on to the next graph. So this is for Algebra 2 and Precalculus. We need to find the domain and range of the following function. So again, domain, which means we're gonna go from left to right. Alright, left, we see that the arrow point to the left right here. So it's gonna go forever to the left. So we have negative infinity less than. Now we see we have a hole right here and the hole right here, right? The hole right here right at negative 3. So we need to exclude negative 3 and the hole right here right at 0, right? So we need to exclude 0. So it's going to be, we need to write this one as the interval notation. Alright, so we have negative infinity parenthesis, comma, negative 3, right? We don't include negative 3, so we put parenthesis, union of negative 3 to 0. And then union 0 to the vertical asymptote right here, right, s equal to 2. So it's going to be 0 to 2 right here. Don't include the vertical asymptote. Alright, next one. After 2, we see that the right range right here. So it can be union 2 to infinity, right? 2, and then the arrow point to the right. So it could be positive infinity. This is the domain for this function. Now the range. Alright, so we're gonna go from bottom to top to find the range. Now bottom, we see that the arrow point all the way down to the bottom with the arrow. So it should be negative infinity. Now move slowly up to the top. So we see that the horizontal line meets the graph at this point first. So this is going to be, right at this point, it's going to be like around negative 0.7, right? So negative infinity to negative 0.7. Union negative 0.7 until this guy right here. So it's close to the horizontal asymptote. The horizontal asymptote right here should be y equal to negative 1/3. From negative 0.7 to this guy right here. So this guy less than negative 1/3. So it should be negative 0.6. Right? So it's going to be negative 0.6 union from negative 0.6 to the horizontal asymptote right here. So it should be negative 1/3. And then the upper range right here from negative 1/3 to positive infinity, because the graph keeps going up forever right here. Alright. Now let's move on to the right hand side right here. Now domain from left to right, so you see that the arrow points to the left forever, right? So this negative infinity, so it should be negative infinity to the vertical asymptote right here. Vertical asymptote s equal to negative 2. So it should be negative 2 right here, close parenthesis. Union negative infinity to the holes right here. The hole right here is going to be 1, right? The hole is 1. So it could be negative 2 to 1. Union 1 to positive infinity. This is positive infinity. So it could be 1 positive infinity. Now we need to find the range of this one. So range, we start from bottom to top, and you see that the graph has the arrow right here, so it keeps going down, right? So it's going to be negative infinity to all the way up until the horizontal line right here. Horizontal line, which means y equal to 2. So it could be 2 right here. Union, right? The upper range right here from 2 to the holes right here. The hole right here, so we estimate is about 3.2. 3.2. Alright. Union 3.2 all the way, right? This is 3.2 all the way to infinity. Now let's move on to the next example right here. We need to find the domain. Right, from left to right, we see that the arrow keep going forever to the left. So it's going to be negative infinity to the right. So it could be the vertical asymptote, it could be right here. The vertical asymptote is equal to 1, right? So negative infinity to 1. Union 1 to positive infinity. Now the range, we're going to go bottom to top, right? Bottom, we see the arrow point to the point forever to the bottom, right? So it could be negative infinity, right? All the way to positive infinity, right? So right here, the arrow point keep going forever. We don't have the horizontal asymptote, so it could be positive infinity. In other words, it could be all real numbers. Alright. Now, let's move on to this one. So we have 2 vertical asymptotes, we have 1 horizontal asymptote, we don't have a hole. Now look at this one. So the domain from left is going to be negative infinity, right? Because we have the arrow. So it's going to be negative infinity to the vertical asymptote. This is the first vertical asymptote. Alright, so it could be to negative 2. Union negative 2 to 3, right? The second vertical asymptote right here is equal to 3, right? Negative 2 to 3, right here. Union 3 to positive infinity. Now, the range, we're going to go from bottom to top, right? So we see the arrow point to the bottom forever. So it's going to be negative infinity all the way up to horizontal asymptote right here, right? But because we have the graph inside right here, this guy right here, we still take this value right here, right? So the range should be negative infinity to positive infinity. In other words, it could be all real numbers. Now let's move on to the next one. We need to find the domain. So you see that the arrow point to the left right here, so domain start from negative infinity to the first vertical asymptote right here, negative 3. Union from negative 3 to, don't forget the hole right here. This example is different from the previous example. Previous example, we don't have the hole right here. This one, we have a hole. So we know that the hole right here is going to be 0, right? S equal to 0. So it could be negative 3 to 0. Union 0 to the second vertical asymptote right here, 2. So 0 to 2. And then union the second vertical asymptote all the way to the right. So it can be 2 to positive infinity. Now, what about the range? We're going to go from bottom to top, and you see that the arrow point down to the bottom. So it could be negative infinity. And then we keep moving up until we see the first hole right here, right? So the first hole right here, right, s y equal to negative 0.7. Union negative 0.7 to positive infinity, right? This guy keep going up forever. Now, let's move on to the next one. We need to find the domain and range of this function. So we start with domain. We're going to go from left to right, right? We see the arrow point to the left, so which is this negative infinity. Until the first vertical asymptote right here. And on the left hand side, we don't see the hole, right? So this vertical asymptote right here is going to be negative 1. So negative infinity to negative 1. Union from negative 1, right, the middle one right here, to the second vertical asymptote, which is 3. Union from 3 all the way to in positive infinity right here, because you see the arrow right here. So this is positive infinity. Now the range, we're going to go from bottom to top, and we see that this guy keep going forever to the bottom. This guy same thing right here. So it could be negative infinity all the way to positive infinity. This guy keep going forever right here. And we have no horizontal asymptote. Alright, so this should be positive infinity. So this is, in other words, this is all real numbers. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.